Alright, now that we've learned a little bit about quadratics and how to find mins and maxes, now we're going to focus on some models, some word problems. And throughout this section, we're only really going to do, let's see, 3 questions. But throughout this section, instead of grabbing the calculator, and you know how we used to do it, we'd take it, we'd graph it, and we'd find the max on the calculator like that. Instead of doing that, we're going to practice using this negative b over 2a. And remember what that finds. It finds the x-coordinate of the vertex. Okay, so here's a typical question if you look at number 1. In economics, we have revenue, R, that's how much money we're making, the money received, selling price, P, and the number of units sold, X. And so it kind of makes sense. If you look at this little formula here, revenue is X times P. So, in other words, how much money I make is the price at which I sell something times how many units of that I sell. And hopefully that makes sense. Let me know if it doesn't. And then we look at a typical question once we decide what the X and the R and the P stand for. And the question looks like this. If we're selling TI calculators and we find that the number of calculators sold follows this linear formula here, where P is the price, then it says part A, express the revenue as a function of P. So first, here's revenue as a function of X and P, right? Now if I want it just as P, we're simply going to substitute in. So we know X is tied by this 21,000 minus 150P. Alright, there's my X and then my P. And then if I want to start minimizing and maximizing things, it's best to go ahead and distribute that through. So if I distribute that, now I get 21,000 minus 150P squared. So this is the best looking revenue function. Now it says at what unit price in part B should be used to maximize the revenue. As soon as you see that, we need to start going into negative b over 2a. Now it says what unit price P, so P instead of X, negative b over 2a. And if I crank that out, just keep in mind, this 21,000 here, that's your B value, even though it's written first, because that's the one attached, oops, I missed it, attached to the P to the first. So negative B, negative 21,000 over my 2a. Alright, now we might want to grab a calculator to do that, but it ends up being $70. So again, we're using a calculator for some of this kind of stuff, but we're not using the calculator for graphing and finding the min-max. Alright, and then part C says, if this price is charged, remember this $70 is the price, if this price is charged, what is the max revenue? So now we're going to go back to our revenue function as P, and we're going to plug in our 70. Alright, and then if I do all that, again, we'll need the calculator for a little help here. But let me write it out. Alright, crank that through the calculator, and I get this nice number of $735,000. Okay, physicsy people, this question here should get kind of familiar. So we have a projectile, or we're going to kick a ball or throw a ball or something, and this time it's off a cliff 500 feet above the water with an inclination of 45 degrees. That right now to us is not super important because they're going to hand me the formula here in a minute, but that's good to know for later on. 45 degrees with a muzzle velocity of 400 feet per second, and then the height equation as a function of x is given by this function. So if you can picture this, let's picture this 500 feet way up here. Here's my projectile, fired off the cliff, up it goes, then back down to the water down here. So that's just kind of an idea. Now, technically the parabola goes this way, and we end up with a negative back here, and we'll kind of talk about that in part C and what that means. Alright, now, if we're not going to graph it on the calculator to find mins and maxes, it's probably going to be best if we simplify this original height equation a little bit. So that negative 32 over 400 squared, I'm going to go ahead and simplify that with my calculator and get negative 1 over 5,000 x squared and then plus x plus 500. That's just going to make the negative b over 2a a lot easier. So if I do that for part A, at what horizontal distance from the face is at the maximum, then we're going to go negative b over 2a. And if I simplify it, it's a lot easier now. So negative 1 over 2 times the negative 1 over 5,000, that's my a value. If I do a little flip and multiply here, I get 5,000 over 2, which is 2,500. And again, that's the horizontal distance they were asking for. And so remember, x's are my horizontal distance, and then my y's are my vertical distance. So whenever you see the word horizontal, you want to make sure you're giving an x value. And then if you look at part B, it says find the max height. Well, the max height is my y value. So now I can come in here with my new number and find h of 2500. And then once again, with the use of the calculator and all these big numbers, I end up with 1750 for the vertical distance. Okay, now here's where the math gets a little bit kooky on us. If we look at part C, let me go a little bit smaller here so I have more space. All right, this one is now saying, at what horizontal distance, okay, so remember, anytime you hear that, you're thinking x, from the face will the projectile strike the water? So looking back at my picture up here, here's where it hits the water, right there. So in other words, when is the height 0? So if I ever ask when does it hit the water, when does it hit the ground, I want to know when the height is 0, what is the x value? Okay, now this one's a little bit complicated because we've got to use quadratic formula. There's no way, no how that thing factors. So if I go into quadratic formula, take a look at what we get. Kind of a mess, but here we go. So I get negative b plus or minus square root. All right, b squared minus 4ac. All right, all over 2a. All right, now I keep saying that we're not going to graph it, but certainly we'd use our calculator to do that. You can always check by graphing, so if this is a quiz test question, you have your calculator, certainly you can check, but I definitely need to see a little bit of this algebra here. And then if I do that, I get two values, negative 458 and 5,458. Now, obviously the negative's no good, right? But that kind of corresponds to the graph. If you look back up here at the graph, that negative 458 is this guy right here. Which again, if we're talking about distances, we don't want any negatives. So we're going to go with only this positive value. Okay, now this last question, this is going to be kind of the craziest one you'll see. This one is, it's a window, first of all. We have a rectangle. All right, let's start with that. And then this word surmounted, that just means the semicircle is on top of the window. And if the diameter is equal to the width of the window of the rectangle, then that means the semicircle is going to fit perfectly on top here. Okay? Now, that wasn't the best picture in the world, but just pretend this is a perfect connection right there. Now, the perimeter of the window is 20 feet. When I say perimeter of the window, I'm talking all the way around the outside pieces. So if I were to trace it in red, we're talking all of this on the outside. All of that red is the 20 feet. All right, now what we've got to do, we've got to figure out where in the world is the best place to put an X. You could put it a ton of different places. But for me, when the algebra all shakes out, letting X be the radius of the semicircle, that's going to be your best bet, because then it's going to be less messy in the end. Alright, so X is radius of semicircle. Now this one's going to get messy no matter what, so let's just take our time a little bit here. I'm going to move this up. We're going to need a lot of room to write, so kind of get used to that. That's probably pretty good. Alright, here we go. If X is the radius of the semicircle, okay, that's a start, and it's equal to the diameter all the way across, then this length has to be 2x. Okay, good start. Now, perimeter includes this little curvy piece up there. When I say the curvy piece, now I'm talking about circumference. Alright? But it's not a whole circle. It's only half the circle. So I want to talk about a half circumference being pi r. So if I want the circumference in terms of x's, the half c would be pi x's. So this little black part up here is pi x. So let me highlight that one more time. Just the semicircle part. Okay, so I've got the round part labeled. I've got the base labeled. Now I've got to figure out how to label these two pieces here and here. Now it's very similar to the farmer and the fencing idea. You've got a perimeter and you've got all the outside pieces. So consider this for me. The height, the little blue piece that I just highlighted, is going to be the total perimeter minus the base minus the half circumference, and then all over 2. Remember, all over 2 because I have two congruent sides here and here. So I need to cut that in half. Okay. Okay, so now I can start piecing together a nice little area formula. So I want to admit the most light is what the original question says. So max amount of light. So my area, if I begin with just my basic equations, I have half pi r squared, because it's half a circle, plus a rectangle, base times height. Now I want area as a function of x. So if I do that, I have a half pi x squared plus base of 2x, height of 20 minus 2x minus pi x all over 2. All right, take a minute, kind of soak that in. If you have to hit pause, go for it, because now we're going to start cleaning it up just a little bit. All right, so cleanup stages go like this. There's not a whole lot I can do, but I know these 2's would make each other go away. I also know that when I distribute my x through, I get, okay, because the first guy stays put, no big deal. Now distribute the x through. Okay, now remember, it would be nice if we could just graph this thing and see the max, but for this lesson, I really want to focus on using negative b over 2a. Well, the b part's easy. Here's the b part, all right? But the a's are all of these x squareds. So I need to figure out algebraically the best way to combine them. All right, so let's talk about this. We have a positive half x squared pi right here, and I have a negative 1 x squared pi here. So if I have a negative 1 pi and a positive half pi, and I add them together, I get a negative half pi of that. And then I still have this negative 2x squared hanging out here. And again, I'm going to move my b term over so we can see a little bit better. All right, so I can see my b term for sure. Now my a term, if I get only the x squared by itself and leave everything else in the parentheses, let's write that out. Now, finally, I can see that this value is my a. Now I can start tackling negative b over 2a. Okay, so consider this. Negative b over 2 a's. So again, I finally got my a's all set. And then I crank this out, simplify a little bit. Let's see if I simplify in the bottom. Here's what I get. So now, if I ask for an exact value, that's about exact as they get. Probably I'm going to ask you for a rounded value, though. So if you want to go ahead and put that in your calculator, I end up with 2.8 feet. Okay, now, if you go back up and read the instructions really carefully, they say find the dimensions. Now, when I'm asking for dimensions, that means I need all the dimensions in the problem. I need a radius, I need a base, and I need a height of the rectangle. So I need to find all three of these values. Now, this x, remember, if you look back up your picture, x is the radius. So the radius, kind of nice, 2.8 feet, that part's done. The base of the rectangle, remember, was 2 x's. So if I double that, I get 5.6 feet. Not bad again. Okay, the height's the kooky one. The height, if you look back up the picture, let me write this out again, is this crazy thing, which means I have to take 2.8, plug it into all that, and then believe it or not, when you pop that out, I end up getting 2.8 feet back again. Okay, so these three values here would be the final answer.